Guys, it will start. Thank you for being here today, despite everything that's going on in the week. I know it's a packed week for everyone. The topic for today's discussion would be RAG models, retrieval, argumentation generation for LLMs. A little bit about me. My name is Purbid. I'm a second year graduate student pursuing MS in 3S, and I'm a part of Utah NLP, and I work in generative LLMs and explainability with Professor Daniel and Professor Anna. Um, all right, let's look at the lecture plan for today. In the next 50 minutes or so, we're going to cover broadly not just the meta RAG model, but the general landscape of what retrieval argumentation entails. And my plan for the lecture is to go sort of keep going back and forth between the actual model that was proposed by Meta in 2020, but also what came before that and what has come since. And we'll discuss specific details of the models, but we'll also discuss the underlying principles that apply to each and every model that we are going to look at. So, yeah, let's first of all look at what are actually RAGs. And it's just that the name RAG has been hijacked by the model that was proposed by Meta. But generation that is facilitated through retrieved documents has been going on for decades. Like the earliest Google search that you would see, that was built off of triples or semantic search, wherein you would get subject, object, and target of a word by semantic parsing. And then you could use any sort of a non-neural retriever like BM25, TF-IDF, or any other algorithm to get the most relevant documents. In recent years, retrieval, be it neural or non-neural retrievers, have especially come back because now you have LLMs. So you could essentially use these retrievers to provide extra worldly context to LLMs such that they generate factual knowledge, which they could not before. I mean, they can generate factual knowledge, but it has been seen that LLMs hallucinate a lot. And secondly, as the models keep growing and the pre-training data size keeps growing, you cannot condense all of world's knowledge into an LLM parameters. And that is why with increase in size of pre-training data, it becomes essential to have what these people call as non-parametric memory, which is memory that is not stored in weights or biases of the model. So an external data source. So any RAG model will contain these three components you would want to retrieve, and which is essentially given an external database or non-parametric memory. Retrieve the documents that would facilitate a better generation or more factual generation. Argument, which is basically combine this generated documents with your input query, and then you feed it to the LLM, and it's up to you how then you generate the actual responses. That's the general. Uh-huh.
Basic question. So I'm not from like a
Sure.
NLP background, but the argument is kind of something like fine tuning.
No, argument is basically how do you add the documents that you received to the input that you would have provided to the LLM anyway, so that now the model or the LLM can answer your question based on these external documents. Like, for example, if I asked who was the Prince of France in 1700, more likely ChatGPT can answer that question because it might have been trained on Wikipedia documents. But if I asked it a question from, let's say, yesterday, like what was the temperature in Salt Lake City yesterday, it will not have that data in its model weights because that would not be a part of pre-training data. So it would most likely look at some external sources on the internet, then add that to my question, what was the temperature in Salt Lake, and then give an answer. So argument just means appending or adding it to your input question. Yeah. Okay, so now that we have an idea of what RAGs do, we're going to dive into what to me was like a good seminal RAG paper that was called RELM, which was basically retrieval augmented LM pre-training. And this paper was effective in showing that you could take a knowledge retriever, which is basically a model, a BERT model, that can look at documents. It will take your query and it will fetch you the top K or top one documents that would be most relevant to your query. And it would take a knowledge augmented encoder, which is again a very fancy term for a BERT model that these guys were using. Remember these papers, RAG, RELM, And most of the early RAG model papers came out in 2019, 2020, 2021. So you would not see these models use GPT-3 or Claude or those fancy models or ChatGPT for LLMs. They were based off of BERT, and then we'll see another model later, which was based off of BART. And now it has been very recent that actual models like ChatGPT are being used in the LLM, ChatGPT or Llama, because ChatGPT is close source. Anyway, so this paper focused on joint pre-training of a retriever, which was a BERT model, and a knowledge encoder, which was also a BERT model, using mass language modeling. So these people explicitly showed that if you train such a architecture in a joint setting, you can use it on open domain question answering. And we'll get to why open domain QA. And this is one thing that Meta's RAG model actually expands on. It just now gives a general sequence to sequence architecture, and you don't have to specifically train on open domain QA. But as far as Realm was concerned, only works for open domain QA, or at least was only fine tuned on open domain QA. And one salient feature for this model, or where it differed from its predecessors, was it would train the index model every few hundred steps. We'll get to what an index model is, or why is it significant to train the index model. But overall, Realm, what it would do is you give it a question, it would take that question, it would create an embedding out of that question, and it would then look at all the document embeddings that were done beforehand. And when I say embeddings, these are just document vectors. You go into that vector space, you look at the top K results that match your question embedding, you get those top K results, and then you append that to your query. And then you do some sort of a task which is different for pre-training and different for fine-tuning. You do a task that helps the retriever and the generator learn together. So the idea is, since you would want to train, well, it is preferable to train on an unsupervised data set, because like having labeled data sets is not very feasible, especially for pre-training. So what these guys did was they tried mass language modeling for pre-training, and for fine-tuning, since this is a specialized model for QA, they are using just general extractive question answering. But let's take a look at the left-hand side of the diagram, I guess, right-hand side for you. I don't know. The pre-training part. First, we'll have an unlabeled data set wherein you would have some mask there. It'll retrieve the knowledge, it'll retrieve a embedding or top some embeddings from the corpus. And with the new query plus the embeddings from the retriever, it would try to predict this mask, right? Basic, simple mass language modeling that most of the models have used since transformers. At the fine tuning time, same thing happens, but now there's no mass language modeling. You get the context from the retriever side, and then you are appending these contexts like how you would create the input context for a BERT model. So you would have a CLS token, your query, and then your SCP token, which is a separator, followed by all the documents that you fetched. And now this becomes a question answering problem wherein you have to find a span of where the answer lies between these retrieved questions. It's a little tricky the way these people have proposed their model, because from the abstract, at least I thought that this was a generative model, which it isn't. It's mostly it's actually an extractive model. Like, it'll give you a span of answers that it found inside of one of these documents, right? So I guess we can dive a little deeper into the knowledge retriever and the encoder or generator, but do you have any questions before that?
Is it possible to use a different source rather than documents as the kind of external data? Could it be a camera or a microphone?
It could be, because ultimately all these documents are used for is getting an embedding space. I mean, getting embeddings that you compare the query against. But
Does that happen before the query, or like could it embed things live?
okay, this model, so to begin with, every model has to embed it before the query, but during pre-training, you would see that they periodically update these embeddings as well. But newer models like RAG or other models, now they have a fixed embedding which is unchanged throughout the training. Yeah.
So during the screen training, it's like training like end to end.
Mhm.
So that each document just starts off being embedded, just like random.
They use off-the-shelf BERT for an initial embedding, and then every 500 steps or so, the entire embedding space is regenerated, and then indexing is redone.
That's just based off this like tree signal.
Yeah,
Like,
for mass language modeling. Yeah. Right. Um, yeah, like I said, knowledge retriever is a standard BERT model. You get a query, you run it against the documents, and then top key documents are fetched. This is the first bottleneck now that we can discuss, is that it is easy to calculate the top K documents by simple dot product if you have 100 or even 1,000 documents. But when you're talking about Wikipedia, these people use a span of, I think, 200 odd word piece tokens, and then the size of your documents become 13 million, because entire Wikipedia and each document is 200 words, 200 words, 200 words. How do you, if you were to calculate the dot product of your query with all of these documents at each step in the training, like, may God have mercy on you. So what these people do is MIPS, which is maximum inner product search, which is crudely, you can think of it, you can create like latent buckets inside of your huge vector space, huge embedding vector space. So you don't have to take the dot product with each and every document to begin with. You can take the dot product with these clusters, so to say, and whatever cluster has the best result with, then you can find out which document or which top 4 or 5 documents have the best matching, and that is how you, in like sort of 2 steps, you could get the top documents way faster. Also, BERT is used to get initial embeddings, and then this is to answer your question as well, that initially you would have a search embedding space and consequently a search index created out of BERT, and then you would update it periodically. It implements an inner product search between your between your input embeddings, and this input embed X is a query that you pass to the model, and then your document embeddings Z, which is you create off of Wikipedia. An important thing to note here is these embeddings are both created from the same BERT model initially, but we'll see, since we are not updating the document index or the document store very frequently, there is a fixed span between step 0 and step 500, wherein your model keeps getting updated, your retriever model keeps getting updated, and consequently, your input embeddings also keep getting updated, but your document embeddings are fixed. So it's a little confusing to think of it, because then you're essentially comparing two documents, or you're, sorry, not two documents, you're comparing two vectors, so you're trying to find top K matches from embeddings that were created in different spaces, or from embeddings that were created using different parameters, right? But as it turns out, that's not that big of a deal, because every few hundred steps they are updating the original document embeddings as well, and they are like, that's good enough for us. So yeah. um Okay, that was for the retriever. Next is the augmented encoder. Again, BERT model trained on MLM for pre-training, and then we use extractive QA for fine-tuning. One thing that these guys, well, not proposed, but have used, and it showed like they were very good at using this, and results were better, was salient span masking. So the idea is, if you are trying to generate an answer for a question that is facilitated by a bunch of documents, you want the model not to just read at particular words or sentences and get those answers by like right from that. So what I'm saying is, if the answer is verbatim, like picked from the document, if the question is, who was the president of France 20 years ago, and then if one of the documents which was retrieved has this exact sentence of who was the president of France 20 years ago, and then name of that person, that's a problem, because then the model is not looking to really generate or search through the documents for an actual result. It'll just look for an exact string match, and then it'll not really uh, learn anything, right? So what these guys did was, especially during pre-training, salient span masking. So instead of randomly masking out 15% of the words that you would do in any transformer or BERT, you use NER to make sure that words that were worldly entities, so the year 1989 or United Kingdom or something like that, could be marked so that it would make the model sort of more robust, and then it would not just pick up certain instances while predicting the next word. Also, trivial candidates were excluded from top K, which means that I think I explained the trivial candidates first. My bad. So what this means is if you get like 5 documents and the answer to your whatever mask that you want to fill is exactly based on document one. So basically the sentence that you're trying to unmask through the pre-training comes from document one, then it's just gonna like copy the exact word at whatever the words that are unfilled, it's going to take and then fill in the mask, which will not work. So if my query comes from a certain document, I will remove that document from my top K documents at all. And a natural question is, well, wait a second, why will the query come from my documents that I'm using to create the index? Like if my index comes from Wikipedia, why am I pre-training on Wikipedia as well? And the answer is like they've tried out both the approaches wherein your pre-training corpus is different than your document embedding corpus, and if it's same. The results are better, obviously, if it's a different corpus, but both of these approaches outperform any previous models. So yeah, that is the significance of point 3 here, I guess.
It seems like if you're just trying to predict masks,
Mhm.
you're always just gonna be kind of like looking for like something almost identical, and just pulling out the same word, like
Yeah,
what's on top of a pyramid, you're gonna look for like blank is on top of a pyramid.
exactly. So
So
that's the reason that they remove the trivial candidates or documents which have a very high probability of having those exact sentences copy pasted.
I guess, but without that, you can't answer the question, right? And so I guess, I don't know, yeah, it seems like there's no way to get around this idea of like,
Well,
if you're just asking out, you know, 1 or 2 words,
mhm.
you're gonna have to have some document in your database, right, for like,
Yeah.
as an almost identical sentence that you can like say, oh, I can't, here's the word that's missing.
Oh, yeah. You can have documents that talk about the same thing or can be almost identical. What they want to remove is exact documents from which the input is being taken while mass language modeling. So if it's 100% match, same string, they don't want that. But
To make it a little
yeah.
harder. In these cases, is a document like an entire Wikipedia article, or do they like
Chunk it into 100 word or 100 token documents. So if you have an article that's very long, you could get like a couple 10, 20 or whatever documents out of it. Overall, I think their size is 13 million or 21 million. I'll confirm
there are
that.
like small enough chunks?
Yeah.
You have this worry that like embedding.
Yeah.
It's just gonna be kind of letting you know whether it's an exact match.
Yeah.
It seems like the longer the document, the more kind of
Exactly.
abstract.
Yeah.
Like embedding has to be, but maybe the less useful it is, right?
Also, the thing that they'll fine tune it on later on will be QA, right? And that's not super long spans as well. So it makes sense to have the pre-training data spans also very short to mimic that document structure.
The idea would be that you have like some separate data set that you're using for, that you want to like have available for RAG.
For?
Right? You're not using like pre-training.
For fine tuning?
Your retrieve.
Yeah, so your retrieving data can be the same as pre-training or it cannot be. The performance differs in both of these model variants, but it is generally preferred to have a different pre-training set than your document corpus.
Well, you said like 30 million documents, right? That they were using in this paper.
No, they're using the entire Wikipedia set, and like if you break down, like let's say you have one page, right? You take 100 words and that's one document. Next 100 words, that's next document. So they have 21 million documents in doing that. Yeah.
From the like 21,100,000.
Yes. All right. This was like the overview of the retriever and argument encoder. Also, it might feel like we're running out of time, but this architecture forms literally the base of all RAG models. So we can actually just look at RAG and we can talk about what different things did Meta's RAG model use, and it'll be fast. No worries. Um, then the main components of a RAG model, if you are essentially trying to predict the next word during you're trying to predict the masked language. And then if it's a generative model, you are trying to predict the probability of a Y, which will be the mask token given your X, which is the context, right? So these people model it as a joint probability, or like a product essentially of these two terms, which is probability of Y given you have the retrieved document Z, which came from a set of not a set, but an actual query X, which is this thing that comes from the encoder. And then you first have to get to the Z, or which is you have to get to the top document, right? That comes from the retriever. So this is a product, and you marginalize this over all sets of documents, or at least all documents that you retrieved, right? Now, the first thing here is your general mass language modeling. Given your context, which would be Z comma X, you want to get the Y, which is the token. There's nothing like new here. This is standard MLM with the transformers. It's just that you are now appending the X to the Z, which is you are appending the query to your document which was retrieved, right? This thing is much more interesting because, like, how do you get from your documents which were retrieved using in a product search, and then you make sure that this document is relevant? Because if you're gonna update based on the backprop on the gradient backprops of your mass language modeling every 500 steps or so, like, there has to be some sort of a signal that says that this Z document that you retrieved was good or it was bad. And the way these people do it is they call this thing as a relevance score, which is basically again a dot product between your input query and your document embedding. And the question is then, like, if the learning is unsupervised, how do we know that the retriever knows that the document was good? And the answer is they add this um, term called RZ to the gradient that you get, and not add, sorry, multiply or factor it. And they've made this term in such a way that if the numerator is greater than denominator, this entire term becomes greater than 1 and essentially positive. So RZ becomes positive, and that would signal the model to say that this document Z that you got here, that actually really helped me. And this is why, with respect to this query, the document was more pertinent. However, if the numerator is less than denominator, which means that Z did not contribute to uh, having a higher completion score than we would have wanted, this term becomes less than 1. Consequently, RZ is negative, and what that means is, like, the model would be far less likely to select the document Z for an input like that the next time. This thing we've already covered. Pre-training is different. MLM and then fine-tuning is just QA. So I'll just let that. Now we'll get to the results. They have trained the model on a QA task, and the results that you see here are on these data sets. So NQ is natural questions. I have WQ is web questions, and then CT is something else that I do not remember. I apologize. But these are all open domain Q question answers, right? The three things that I've highlighted here are something that we would want to look at, which is BERT baseline. Obviously, it does not perform as well. All these numbers are accuracy numbers, by the way. BERT does not perform as well. And Orca is another interesting model that had come just before Realm. And the only way it differs than Realm is the index is not updated regularly. Orca has a fixed index, much like the meta RAG model that we'll see later as well. But everything else, pre-training, hyperparameter, and fine-tuning is same, right? This is interesting because your performance of your realm model is 40.2, and then you can see a model like T5, which is 11 billion parameters, still does not match realm's performance. Also, you can see these two variants of realms that you have here. One is where both X and Z are Wikipedia, and then your X and Z are different. So to answer your question, Alex, like there is a slight improvement in performance when your knowledge base and your pre-training data are different, but it's not that appreciable. So yeah, any questions for this? And this is just with a BERT model. We'll see, like especially with Facebook RAG, that that uses BART instead of BERT, the performance is even much more better. So a lot of your performance would base on your generator. Okay. Can we move to the next one? Yeah, so this is what I just explained. You have your ARCA, which is sort of the comparison baseline for this realm model. And then having different texts for pre-training and external document helps increase the accuracy as well. Now, that was the realm model, and we can get to the actual meta RAG model, right? So first thing is text generation by document seems promising, needs to be explored more, amazing. But Realm does not talk about hallucinations at all. And whenever we talk about RAG models, especially in today's context, we always say that RAGs can help alleviate hallucination. We will now see that actual RAG paper also did not do anything about hallucinations. They just mentioned it in a passing that we qualitatively find out that generations are not as prone to hallucination, but there was no quantitative analysis. But anyway, at least the RAG paper mentions the word hallucination thrice. Realm paper does not mention hallucination. So also, if the Realm paper showed that there's a scope for using autoencoders in a downstream task, RAG wants to extend that to a general sequence to sequence framework that can be used for any downstream task, right? And then last question is, do we really need to pre-train the retriever and generator? Because that seems to take most of the time in pre-training, right? And oh, you, yeah, I'll redo it. Yeah, go ahead.
Sorry, yeah, just a comment on what you said that the round paper you mentioned hallucination.
Mhm.
And I just don't want anyone to interpret that as if they should have mentioned hallucination because they should not mention it, as that was not the problem in 2021. So
Right.
realm is not a generated model, right?
Yeah.
It's, as you said,
Extract
it just gives you the answer. So it's not generating next token, and in this way producing answer. That means that it just won't start spitting some weird stuff.
Right.
So we didn't talk about hallucination because we simply didn't deal with that. And only when we switched to decoder only and generative models, now these models are, and especially when they can become designed for many purposes, in some cases you want creativity, you want hallucinations. Hallucinations are an advantage. And in other purposes like factual question answering, you don't want those hallucinations. So yeah, it's not that they should have mentioned it. And when was the meta round paper?
21. This was in 20.
21. So I suppose, yeah, they also didn't comment it on much since. Yeah, well, it just became a thing. in
Recently, yeah.
2023.
Okay. Drum roll. Yeah. So now we're at the actual RAG model. And this is something that might be totally useless to this discussion, but I thought it was pretty cool, so I put it here. There's a bunch of models in here, and I don't know much about any one of these models except for RAG and self-RAG. We're going to discuss RAG today, and based on our discussion where we leave it today, next time we meet, which would be 16th, we're going to discuss that paper called self-RAG. How did we get here? So this is not at all a very exhaustive timeline because there's so many works in between that have facilitated the advancement and whatnot. But I feel like if you were to sort of peel away what was RAG built on, which was a BERT model, what was BERT built on, and stuff like that. So we had Transformers, which came in 2017, Realm, which came in 2020. 2021 was the Meta's RAG paper or RAG model. And then 2023, we have Self RAG. I've put only self RAG here because that's the topic of our next discussion. It's not to say that self RAG is the only seminal thing that has happened since RAG. So yeah, just a disclaimer. Okay. RAG uses these models in tandem, which is same as Realm. So now this would make much more sense. You index the document, which means that you create an embedding and then you find a convenient way of storing these documents. You could use vector DB, you could use Elasticsearch and whatnot. Then you pre-train the retrieval model, which was BERT up until now, and even is in the RAG model, but you could also use a non-neural model, which can be like a sparse retriever like BM25, could be TF-IDF as well. Nobody uses that because it's not as good. And then finally, you have the generator model. Can be BART, can be a different LLM, can be Llama and whatnot, right? This is the architecture that's proposed in the original RAG paper, and it is exactly the same as Realm. The only difference here is, remember how in Realm we were taking these two off-the-shelf BERT models and we were actually pre-training them on mass language modeling together, then we would fine-tune them. RAG does not do that at all. You take two pre-trained models and the assumption is these models are good on their own. So the only time a joint training is being done is during the fine tuning or the downstream task. And as these people find out, it's actually very good to do it that way. You don't have to necessarily pre-train the generator and the retriever together. So you have the query encoder, which takes your input query, gives you a query embedding, which is QX, then retrieves the top documents using in a product search from the document index, and then you add that to your generator, and then you generate whatever you want to based on your downstream task. Another point of difference here is the query encoder and the document encoder are different models. Now, why is that? Because unlike the Realm paper, these people do not update or re-embed all the documents as they go along. The documents are embedded at the very beginning and that stays the same. You can, however, swap out the previous index or previous embedding documents for a new embedding documents, but that's more of like an embellishment that is not a required part of the training at all, right? Yeah, now, in the paper, they suggested two RAG models, which was one was sequence versus one was RAG token. And I think that's pretty self-explanatory. What the RAG sequence model does, it is gets you a document from the retriever, and then the entire generation, and when I say generation, this is different than Realm again, because Realm was an extractive QA model, but RAG uses BART, which can actually generate a sequence. So like this is how, like you said, this is when hallucinations actually started, when you started using generative models. RAG sequence uses that just one document or whatever top n documents or top k documents to generate the entire sequence. Whereas for RAG token, each token is generated off of a new set of retrieved documents. So it's essentially saying that it is not necessary that halfway through your generation you would still want the same 5 documents. It is possible that you would want different documents. So they were like, here, have at it. Again, this is more or less very similar to what we saw in Realm. The architecture, there's a retriever, which is called a dense passage retriever, model trained on Trivia QA. Trivia QA is again an open domain QA problem, open domain QA dataset. And this is not an off-the-shelf BERT because remember, we don't have any scope of pre-training these models. So they sort of train it on or pre-train these models on some good data sets and not just random BERT base, right? There is a pre-trained encoder just like Realm, which is the DPR model, dense passage retriever. Documents are created once using the document encoder, which essentially means that the document index is never changed. And then the encoder is kept fixed, unlike Realm, which changes during pre-training. Now the models are different. So you have BERT-D and you have BERT-Q, the query embedder and your document embedder. And both those models, again, are used in a dot product sense to contribute to your probability distribution. Exactly similar fundamental to what we discussed in Realm, nothing new here. Generator, however, there's a significant difference. You have a BART model, which is a generative model, not an extractive model. And then retrieved documents are added or concatenated to the context of this BART generative model. And this is responsible for what these people call as parametric memory throughout the paper, which is essentially memory that resides in the model's weights. That was the architecture of RAG. Do we have any questions?
Go back one slide.
Uh-huh.
So when you're saying that the retrieved documents are added to the input, that would basically be the prompt to like.
BART model. Yeah.
So essentially, they're just like pulling these documents, but then just using an extended prompt with like background information.
Yeah. And then you do like sequence to sequence on that. Right. We can talk about training for RAGs and results. Like I said, both these models are jointly only fine-tuned and no pre-training is done in tandem. There is no further pre-training done on MLM as well. And then based on your task, you would have different types of fine-tunings. But in general, it's more or less like language modeling. You're trying to minimize the log likelihood for each target, which is given an input pair of X and Y. So for example, if you're doing this on an open domain question answering site, you would have a gold answer and then you would have a question. You want to minimize the negative log likelihood of getting that answer.
How can you generate the trained and not supervised manner? Generator generates the answer. You need the answers. No?
Yeah, what I meant was the initial BART model was an unsupervised trained model. But like when you fine tune it, so for example, in here you do give it an input pair for question answering. So you have a gold label for that.
I think that sentence still doesn't make sense because you say that both retriever and generator are trained jointly in an unsupervised manner.
Ooh,
It's easier.
right. Yes, this is my bad. Yeah, I think this is incorrect. This should have been supervised. I'll fix that.
So these generative models, so we're thinking like, these are just all trained unsupervised first. And then this kind of takes the place of like the supervised fine tuning.
Yeah.
Kind of normal pipeline.
Yeah.
I think self-supervised would be just more neat when you say, you're still using data that focus and we try to generate of central events. So
Yeah. Yeah.
You said that the documents retrieved changes after each token potentially.
Not for this model. That was in realm. Oh, okay. Yeah, the embeddings remain the same, but yeah, the documents can change. Yes.
That means so the, I guess the query embedding,
Will also change.
that's like a bunch of all the kind of tokens that have been generated so far.
Yeah.
Plus kind of the input.
Yeah. So if you see this part of the equation, it is trying to predict yi, which is the next word, based off your x, which was the original first half of your query, and then your z, which will again change based on each token, and then the generation till that point.
Feel like ZI.
No, because you get a new set of documents every time. It's not just the previously.
Wouldn't it be?
I guess you keep on appending new documents, you kind of.
No,
wipe out all the old documents.
wipe out and create like a new prompt. Yeah. Yeah.
Create a new prompt.
Yeah. Yeah.
That makes it seem like it's the same. Just that equation, it makes it seem. Set of documents.
Are you referencing that in this case in order to figure out why right? So you would
Yeah.
say query the context and then what I've generated so far. So you would be referencing the same context rather than like the context minus anything. It's
Yeah, documents are retrieved from one instance, which is X. X is like a query or prompt, like what means the capital France. So then you retrieve the documents, set disease, and then you can marginalize, not, yeah, I don't know what a marginalize here, it's like an expression, but you just know where the data is. So, yeah. Having the same piece is fine.
But I thought in the token RAG, it was saying for every token you're retrieving a new set of documents.
That's not my understanding.
That is what I think happens.
So Z here would be a returned list of documents for every token, but it would still remain the same.
Yeah, and
the
you're
same
you're
set of
taking
token documents.
you're taking the generation that is done till point I minus one, and then you take that and then fetch out new documents
Yeah.
based off of that, and then you
I
keep
mean,
doing
that's
that.
just why I was thinking that Z should be.
I agree. I think the way this is written with Z is always the see that.
Yeah.
At least X.
So the difference between the two would be, you would take a, Z would be the, like, embedding space or whatever, sorry, I don't have the right words, but for the entire sequence. And that would be one set of documents, but if you did it per token, it would still be the same. I mean, it would return a different set of documents because,
Yeah.
because it would be generated per token, but you would still take all of the aggregate as the kind of source for the generation of the entire response.
I could go back and confirm this because like now you and I'm confused, and I can post it on the channel. 'Cause-
Yeah, because all that's changing.
Right. Yes, we have to move.
The marginalized on like sequence level. Yeah, that's just, that's the only difference, not like retrieve sequence or.
Yeah.
Okay.
Also retrieving in the token. Not be insane.
Yeah. But you know.
Never know.
We live in a nation of the reinforcement in this, the way.
Okay. Yeah, so the evaluation is done on these topics, these data sets. First one is open domain QA, which is the same as the realm model. Then you have your abstractive QA. And what this does is basically it gives you a question and it gives you 10 gold passage retrievals from the search engine. And then you have an answer annotated for each one of them. And you are supposed to generate an answer that closely matches that answer. Third one is interesting. It's called Jeopardy question generation, and it gives you an answer, and you're supposed to generate a question for it. So the input could be Indian cricket team, and then the question could be winners of ICC World Cricket World Cup or something like that. Right. So it's flipped in that way. And then finally, we have fact verification data set called Fever. It's basically retrieval plus entailment, wherein you'll be given a claim and then you would have to retrieve your passages or documents from Wikipedia, and then you append them together, and then you want to say if the claim can be supported by the documents that were retrieved. This is done in three labels, which is support, refute, and not enough information, and then obviously support and refute. As we'll see later, it is much easier to get a good performance on supports and refutes. So performance for Fever would be much better for 2 classes than 3 classes. This is the results for RAG token model versus your closed book approaches and your open book approaches. One interesting thing to see here is the improvement that it gets over Realm for natural questions data set, and essentially every data set that these guys had trained on. And also, it also gets an improvement over T5. I do not know what this, like, there are two values mentioned here. I do not know what that means. My guess is it's either extractive or abstractive, because T5, remember, can generate more results on its own. It doesn't have to pick spans in there, but they mentioned that they choose.
That's what, that's like, the QA wiki test. So there are different splits of the data.
Oh, okay, I see. All right, this makes sense then. Um,
In the rerun the baselines, they just reform these papers are reported with their papers.
Mhm.
That's why they are not, is it for their own numbers, they are reporting all the results, because they're actually running and calculating
Yeah.
the results of those. They don't. Or during the code.
Yeah. Okay. One good thing that they noticed was this does not need salient span masking, which was required for Realm and even Orca model. And then it shows that the training the index is not necessary for high performance, unlike Realm, which does train the index periodically. And then these are the results on fever, jeopardy, and fever and jeopardy. You'd see the state of the art is still MS Macro, which was given a query, it would give you the search engine results, and then you want to find the answer there. And the reason is that anytime these retriever models are trained on a QA setting, you do not want to provide them the context or the documents, because then it just becomes like question answering, how you would do for transformers or birds. You want the model to look at the documents, the entire document embedding space itself, and then figure out what set of documents will best suit. So even though the performance will be much more better for MS Macro, which uses this model pre-training on whatever. This is basically a auto encoder model that was proposed in 2020. But
It's basically Google's, isn't it, or is it an overloaded term? Can we go back to?
this is not the Google spam, no.
Okay, sorry.
Okay.
Confusing.
Yeah. And then, so the performance on all these other data sets, Fever and MS Macro, will be good for state of the art because it provides the model with the context as well. Also, RAG does not have access to these passages, and it is not necessary that Wikipedia will have answer to the questions that are being asked. So that's another reason that they cited that RAG could not perform as well.
This- Because you're saying that RAG doesn't have the context, but my understanding is that the whole point of RAG is to retrieve the context that will help the QA, right?
Right.
Confused by your point that MS Macro is getting the context. that
Yeah.
RAG
So in MS Macro, if you have a query, it gives you 10 documents from Google search or from Bing search, and then it gives you the exact answers in those documents, right? So it already gets the correct gold label top 10 documents. RAG doesn't do that. It goes through the entire index of Wikipedia, and then it's up to like the retrieval to find the most relevant documents there.
So
And then
the
get
difference then, the corpus we are retrieving from, because MS Macro is retrieving from Google and.
No.
RAG is retrieving.
MS Macro is also based on Wikipedia, but it is not necessarily true that all answers will come out of Wikipedia.
I'm still struggling to understand that, but maybe let's move on and ask you.
Okay.
Is it the, point two is because of point three? Like, it's.
Yes.
Rag does not have access, like, there are questions that you.
No, these are different things. So these people specifically remove the context while training RAG models, because if you have the context, that defeats the whole purpose of retrieval, right? And then there's an additional point is it might be possible that Wikipedia doesn't have context at all for that question. Okay, that was the RAG model. Now we'll get to the hallucinations that we've been seeing in RAGs. Well, not really how does RAG deal with hallucinations, but more of an evaluation benchmark for hallucinations and what are hallucinations to begin with. It's 12:46. Is it okay if I go like 5 minutes over? Sorry. Silence is compliance.
Wow. It will be an excellent teacher.
Yeah. So we've seen RAGs and about their hallucination, but is there a benchmark? And the answer is yes, there is. So this is based off of a paper called Links that came out in 2024. And these people proposed two things. One was a new hallucination evaluation benchmark they called as HalluBench. And they proposed a new model as well called Links, which was a fine-tuned llama, and that they used to detect hallucinations. One amazing thing that came out of this paper was they found out the links model, even the 7 billion parameter model outperformed llama 70 billion. So it could take on models like 10x its size. But an interesting thing that these people mention is, and I think like that is important in defining hallucinations, is that hallucination mitigation does not necessarily guarantee correctness. It guarantees faithfulness. So what that means is this is a measure of intrinsic hallucination. Given your retrieved documents and your generation, do these documents and generations align? which is not the same as extrinsic hallucination. That is the answer actually correct that you generate? So you could have a incorrect set of documents being retrieved and then an incorrect retrieval as a result of that. But if these things align, that's still mitigation in their paper's term. Um, I'll just quickly glance over how is this data set created. They get like different data, they have different data sets that are mentioned here. They randomly sample 500 samples from it. And then from those 500 samples, they create new 500 samples, each one of which has some sort of hallucination induced into it by synthetic manipulation. And they do that by using GPT-4o. This is the prompt that they use for that. So they ask, how can we change the gold standard subtly so that it would be wrong? The answer should still lie in the context, but it should be incorrect factually. These are the results for the links model on Halu Bench. You can see that it outperforms Llama, it outperforms GPT, it outperforms basically all the models. This this thing that I've highlighted, Raga's faithfulness, is another or a previous framework that was being used for hallucination evaluation, which was totally based off of LLM. So in there, you would give it a question and an answer, and you would ask like generate me an answer, and then using LLM as a judge, it would then tell that if this answer is a hallucination or not. So these people say that they find a much more drastic improvement than this framework. So, any questions? Okay, I just have one more minute and I can talk about in context language retrievals, in context realm, sorry, in that. And this is basically the name says it all. You don't have to train the retrievers and the generators together. Turns out if you have an LLM which is large enough, which is good enough, you can just append the document or the retriever to that, and nothing has to be trained again. Nothing has to be fine tuned. So these people actually take a model, the RAL model, which explores or tries to minimize the perplexity basically through two design choices. One is your stride and one is your query length. So what stride means is how often do you want to retrieve the documents that you're gonna append to your query, and then query length is if you are appending documents to your query, right? You have your x plus your z. How long should the query be that you use to retrieve documents periodically? And these people play around with these hyperparameters, and they found that the best combination was to use a stride of 4. So you retrieve documents every 4 tokens that are being generated, and then the best L, or the last number of tokens, was 32. So the reason for that is it should have the latest document which was retrieved so that it can have the latest context, and then after that document you append the x which was the original query. Also, another cool thing is this thing worked better with the BM25 than it would work with a BERT. So a non-neural retriever performed better in case of in-context RAM. I think I'll stop. Next meeting we are gonna discuss self-RAG, and that's it. Thank you.
Okay, sorry, can I just ask about this last bit?
Yeah. I just ran through it. Yeah.
I basically didn't get like we are generating, and every few tokens we generate, we retrieve.
Yes.
Difference, but
Yes.
the whole pipeline is the same. We are still using the embedded studies.
Yes.
I saw some perplexity there for a moment. So.
Oh yeah, the performance is determined on perplexity, but the generator or LLM is never retrained. The weights are never changed, which is the difference between this and the models we've been seeing till now.
Is the retriever trained or?
No. Actually, I'm not sure. I'll have to look that up.
Because assumption if you have.
Yeah, because
It's
then.
like a really good pre-trained model, and so regeneration will just get embedded, something that will be close to where the documents are embedded.
I think the
products.
Yeah.
Zero shot will give you good data.
Well, they do have zero shot retriever and a predictive retriever as well. So zero shot is basically like what you said, and then in predictive they take a Roberta model and then they train it to re-rank the retrieved documents. So it does some reordering with the top K documents.
Retriever.
Oh, the retriever is BM25, so it's not not
What is that?
trained. It's basically a TF-IDF sort of a model, which is again a non-neural model. So it has a fixed statistical formula wherein you take the number of occurrences of a word in a document, then you take how many documents does that word occur in, and then you do some fancy log stuff, and that gives you a score for a word, and each word then gets something like that. I don't. It
This is kind of like what search engines were doing back in the day. Probably
Yeah.
something like that, we just kind of-
Yeah.
So I think the reason I was confused is because this is probably, I see that it's published like a year ago, only one over a year ago, and probably at that point, we didn't have this 128,000 tokens context, and it wasn't obvious to just grams of information in the context. Because for me, like if you didn't show me this and you told me, use a, I don't know, ChatGPT as a generator, I will retrieve the documents and put it in the context and generate, right?
Yeah.
That's the first thing you would try. So what I'm hearing here is basically they did that, but a year and not even a half ago, that wasn't so obvious that it would work because the context length was shorter and maybe we didn't put such long documents in the context.
Well, you're saying for the retriever?
Or this in context now.
Yeah, so you're saying the reason that they fetch documents every 4 strides is because they couldn't have the entire context at
No,
once.
I'm saying, I don't want to be that person that says like, why is this interesting or whatever, but I am a little bit confused with what is their exact contribution, since the most basic approach today would be to take ChatGPT
Yeah.
and put the retrieved documents in the context, right? So
Yeah.
here it seems like they were the first one that had tried that, and maybe just to understand why that was very novel at the time would be because in June last year, we didn't really do this,
Mhm.
right? Like the beginning, the context like was shorter,
Yeah.
only when GPT-4 was released was 128,000 or so, right?
Yeah.
Right, cool.
Okay. Cool.
Thanks for-
All right. Yes. I will. Do I need to pause the